Hello, today I'm going to show you Windpark Manager from HPE. Windpark Manager is a comprehensive solution for the technical operations management of wind parks. It accelerates and automates technical operations workflows and enables wind park operators to manage a larger fleet of turbines with the same operations team. Currently in the wind energy industry, it's difficult to cost-effectively manage large fleets of turbines, even more so when fleets have different turbine models. This is due to a lack of heterogeneous management systems available in the market. Usually, wind turbines are deployed across different geographical sites, many times in remote locations, and Windpark Manager is the solution to this problem. Windpark Manager reduces the cost of technical operations directly by allowing the same size technical operations team to manage a significantly larger fleet of turbines. Windpark Manager reduces the cost of maintenance and repair due to the better insight and control available at the remote operations center. This in turn reduces the need for expensive on-site visits and enables more efficient bundling of on-site visits for maintenance and repair. Windpark Manager also combines OT and IT data sources in a single view. This includes turbines, traditional IT, and security data, giving the operators a more comprehensive overview of their environment. In Windpark Manager, this is the health perspective, an operator's view into their wind park. You can see the View Explorer, which shows a visual mapping of the wind park. For example, here we see North Sea Wind Park, and within it, we've got a SCADA system, a supervisory control and data acquisition system. This is the current vendor-dependent monitoring solution in the wind energy industry. We also have our turbines and the components within a turbine, such as a blade, cooling system, drivetrain, generator, and so on. This visual mapping is automatically discovered when the Windpark Manager connects to your wind park for the first time, and if there are any changes to your environment, it is automatically discovered and updated here. This is the event browser, the operator's view into the active events in the wind park at the moment. For example, there's a hydraulic oil level low event on turbine 1 on the hydraulics component of the turbine. The hydraulics component is the related CI, and a CI is a configuration item, which is a component in your environment. There are several columns here which provide an overview of the event, such as severity, priority, correlation, notes, instructions, automatic actions, user actions, duplicates, and status. On the bottom, we have the health top view, which is a status tree of your park. So the hydraulics component of your turbine 1 is now in major status. And as you can see, the status is propagated up to turbine 1 and to the park level as well. This is the health indicator view, showing the chosen component's current health indicators. So for example, we have hydraulics oil level showing alarm state. This is the actions panel, which is a list of tools which an operator can manually start. Here we are highlighting the status tree, as it gives a full overview of the current status and allows an operator to perform root cause analysis. An operator can also create a custom workspace with the different components in whichever way they'd like. As we can see, a SCADA connection down event has appeared. This is an example of an IT event. Turbine down event has also appeared, which is an example of an IoT event. This management software can manage both IoT and IT components, and we can correlate that management. Currently, if a turbine down event arrives, a technician must be sent to the wind park to check that the turbine is running. However, it could be the case that it is just a connection issue to the wind park. In that case, it would be a waste of time and money to send a technician on site. Here, we can see that the turbine down events are not realistic. It could just be due to the SCADA connection. In the correlation column, we can see that the SCADA connection event has been labeled as a cause event, and the turbine down events have been labeled as symptom events. An operator can then filter that by choosing cause events only in their filter, and then receive a more realistic view of their event browser. Here we can see in the status tree that the SCADA system is currently in a major state, and the turbine is currently in a critical state. Once the SCADA connection is back up, it will automatically close the bad events and show us that the turbines are back up again. We can see that the events are in a green state and they can be closed by the operator. You can also create a correlation rule in the background, which will close green events automatically. Another example of an IoT event is blade icing, discovered on a turbine. Blade icing has been detected on the blade of turbine 1. Once blade icing has been detected, a turbine must be stopped immediately. So we can see here that the turbine stopped event came immediately afterwards, and again, they were correlated. These correlation rules can be created by operators who can map their knowledge and experience into the correlation rules, automating menial tasks and allowing them to concentrate on more complicated tasks. In the status tree, we can see that the blade is currently in state critical. However, it may not always be obvious what the root cause is. In that case, we can click on the North Sea Windpark and show the problematic subtree. This will lead us directly to the component which is causing the issue. We can see here that the blade currently has an issue, but the drivetrain also has an issue. For the blade, we can open the event browser to see which specific event is causing the current issue. This may be necessary when the event browser has a lot of events coming from turbines. Once the blade icing is over, the turbine is started, and we can see here in the health indicator view that the turbine status is again in running. It has closed the blade icing event and the turbine stopped event automatically and sent them into the archive. This is the performance perspective. The performance perspective has graphs of metrics which show the performance of the wind park. We can feed many different metrics into the same graph. This allows the operator to compare different metrics against each other. Here, we have an event overlay from the blade icing event that happened before. This allows the operator to see exactly what the performance of a component was when the event arrived. These performance metrics, along with the events, can be forwarded to Vertica, a big data database. And pattern analysis can be performed on that data, which can then predict failures in advance and send an event to the event view. We can see here that a predictive maintenance event has been sent. Drivetrain temperature and vibration anomaly has been detected. This is due to the previous events gearbox temperature threshold exceeded warning and vibration in the drivetrain. The operator then knows he needs to trigger a checkup on the drivetrain. He can click on this event and, using the actions below, configure a technician. These tools can also be configured to open a ticket in a ticketing system automatically, such as HPE Service Manager. For security management, Windpark Manager collects security information from the logs on the system and does some basic security monitoring. It is then possible to integrate ESM, Enterprise Security Manager, with Windpark Manager for full security management capabilities. If a security breach is found, ESM can forward the security alert to Windpark Manager, so the operator can see it in their operator's view. As you can see here, an identity theft event has arrived for turbines in both the North Sea Park and the Baltic Sea Park. Technicians use keycards to get into their turbines, and ESM has detected that the same keycard was used in a turbine in North Sea Park and Baltic Sea Park in a similar time frame. This means that there could have been an identity theft, and the operator can trigger a security check on those turbines. Once the identity theft threat is over, the events will be closed automatically. Up to this point, I've only shown the operator's view. Now, I'll show you the business value dashboard. The Business Value Dashboard is a tool designed to give managers and executives a real-time overview of the status of the park. For example, here we can see the North Sea Park is currently in state major. The number of turbines in the park is 2, and in the event breakdown, we have the current active events in the park. In the middle, we've got the most recent events which have arrived in the park, and we also have a weather report and the current energy production. These dashboards are freely configurable and can be designed to look whatever way a customer desires. As a last point, this demo and content is tailored specifically for wind park management. However, the product is highly configurable, so you could also manage solar parks, railway systems, and any number of other Internet of Things applications. Thank you for watching.